Welcome back to this Pig One Nugget. It's not going to be about a hands-on demo. This is going to be more of a lecture. I need you to have a solid understanding of how to handle task failures. It is really important so you can successfully apply it in your Ansible playbooks. In terms of the syntax, we're going to focus on 5 of them. We're going to focus on when to use ignore underscore errors and to set it to yes. So we can ignore the tasks that fail, when to use force underscore handlers and select yes. So we can execute the tasks listed under a handlers section, when to use changed underscore when to false. So the tasks that erroneously report a change at the managed node, we stop them from doing that. How to decide when a task is failed, because there are certain modules, such as the shell and the command modules, that will run on managed nodes and they will not report anything back. How do we search for strings within the output of those tasks so we can decide whether the tasks failed or succeeded? And this whole deal of block, rescue, and always, and the 3 of them go together all the time. And this is basically about uh, dealing with distribution, different Red Hat, different Linux distributions. And I'll go more into this when we get to that slide. But in terms of the syntax, you will have a block of several tasks. So you're grouping a specific number of tasks together under the block section. However, you're saying, well, what do I do if one task in the block of tasks failed? Well, no problem. You can have a rescue section, and under the rescue section, you can have a list of tasks that will still run even if one task in your block failed. Okay, well, what is this always section for? Well, sometimes tasks in your rescue section fails. So the tasks listed under the always section will always run whether the tasks under the block section and the tasks under the rescue section ran successfully or not. Whatever tasks you have under the always section, they will always run unconditionally. Let's give you some examples. So here is an example of ignoring task failure. Please always pay attention to the indentation. Notice that this is the name of the task, but what's important is the module that we're really using for this task. We're using the DNF module, and we're saying that if this module failed, we want the playbook to continue to run the remaining tasks on the managed node. Now understand that this is not the default behavior of Ansible playbooks. The default behavior is if you have a playbook with 5 tasks, if task number 1 fails, the remaining tasks will not run. But here, we are overriding this default behavior. Look where ignore underscore errors set to yes, where it's listed in terms of the indentation, right, with the name of the module. And here we're saying that if we couldn't install the latest version of not a package, right, that's okay. Continue to run the second task and the third task. Make sure that you install the HTTPD package using DNF, and make sure that you use the copy module to copy a file over to this destination at the managed node. And you can see it's really funny because we don't really have a Red Hat package that is called not a package, right? So if you try to search for using DNF search, not a package, it will come back and say nothing found. So this is that. Now, in terms of force handlers, this is also easy to understand. We did go over notify and handlers before as a way to use conditionals in Ansible Playbook. And in this case scenario, we're saying that if the tasks here, if these tasks here failed, I still want the handlers to run regardless. What's really important and what I want you to remember is the location of the syntax is of force underscore handlers. Where is it declared? And the location is in the playbook header. This is the playbook header before you list your tasks. So pay attention to that. In this scenario, we're going to look at when to specify task failure conditions. And this might be a bit strange and confusing, and boy, oh boy, I do not blame you. But here is few things to help you remember. This is normally used with specific modules. 90% of the time, it's either the shell module or the command module. So in this case scenario, it is used with the shell module. Well, why? The Ansible.built-in.shell colon followed by the command that you want to send to the managed node is basically you're sending a command to the managed node to run a specific bash shell. Nothing is going to be reported. When the script runs on the managed shell, you get nothing back. You wouldn't know if the script ran successfully or if the script ran with errors. Well, if we wanted to gather some information about that, you guys know about registers now. Registers would be a perfect way to do it. We're going to use a register so we can save the results from running this module. And we're going to save the results from running this module in a variable called command underscore result. Then we're going to search within that using n and std out, and we're going to search for password missing. If password missing was in the standard out as a string, then we're going to tell Ansible is going to report back and say the task failed because what we have here. Otherwise, by default, it wouldn't report anything back. But with what we have here in this particular task, your Ansible playbook, when you run it for this task, it will come back and say task failed. This is another way of achieving the same results. And we're using a really unique module, and this is the built-in fail module. Interesting, right? To know that there is a fail module, but indeed there is. There is a fail module, and what I love about the fail module is it allows you to spit out an error message. I love that. So take a look at it, right? It is the same task. We have the same structure. We're going to use a register to save the results from running the shell module, right? And in this case scenario, we're going to say, look, we're adding an ignore errors yes, which it means even if you reported that this task failed, right? Because look at this. We have a built-in fail module that is going to write this message out saying that the password is missing in the output, and that's when password missing string is in the standard output. So in this case scenario, I am using the built-in .fail module to have an explicit message displayed as the output of this task. It is something that you don't get if you do it this way in your playbook. So that's the benefit of leveraging and adding one more task for the built-in field so you can explicitly send the message when the playbook runs. Specifying when a task reports changed result. And this is really interesting. This is most of the time is used with the command module. So in this case scenario, we wanted to check the configuration file for the HTTP daemon or for the HTTP server. If you're checking the syntax or the configuration file of particular service, right? Nothing is really changing in the managed node. However, Ansible will report that something changed on the managed node. Let me show you an example. I'm going to come here and I'm going to use my ad hoc command. Okay. Well, let's take a look at this. Before I give you this command, I want you to see where this HTTPD -T came from. So let's take a quick look. If I use a man on HTTPD, here's the man pages. And if I search for T, you will notice that the lowercase t option seems like, okay, so the lowercase t option runs the thin syntax to test the configuration file. Does this really make a change on the managed node? No, it doesn't make a change on the managed node. But if I run it here, let's take a look at this. Escape and do a Control C. I'm going to use this as an ad hoc. Well, actually, I have a playbook for it. So here's I created a playbook, and there is a single play, and the name is validate HTTP configuration. Notice the module I'm using is the command module. And through the command module, I'm sending one command to the managed node, which managed node in this case scenario is Ansible. And I'm going to run the playbook down here. And the name of the playbook is not changed. And even though nothing is really changing on the managed node, if you take a look, it will come and say, changed on Ansible 1, validate HTTP configuration, changed, right? What changed? Absolutely nothing. So to prevent this from happening, because it can affect how some tasks run in your playbook, we can come here and we can mute that and we can say, changed when false. Once changed when is set to false, then this particular task will no longer report this. Okay, so I'm going to modify. I'm going to come here and I'm going to press I for insert. And I'm going to come down here. Okay, and under the module name, I'm going to say changed underscore when colon and set this to false. And I'm going to write this out. Okay, so this being written. And I'm going to come down here. I'm going to clean my screen. And one more time, I'm going to run display. And this time, it will say that nothing changed. So gathering facts, validate, and it says I get an okay as opposed to changed. And that's exactly what I want. In this particular section, we're going to be looking at applying a conditional for multiple tasks. And this is another way to declare conditionals. But notice that this is the first time to use the when clause. So this is always useful when you're trying to execute certain tasks that are dependent on the Linux distribution. So notice here that this block of tasks, and it has two tasks, and these two tasks, imagine that you are managing 20 Linux servers, 15 of them is Red Hat based, 5 of them is Debian based. Well, the Debian based distributions, you don't want these tasks to run on them. Debian based distributions don't have DNF or identified Yellow Dog Update Manager. So for this reason, you can come back and you say, these run when and only when Ansible underscore distribution equals Red Hat. Well, what is this Ansible underscore distribution? It's a variable, and it's one of your Ansible facts variable. Remember, Ansible collects facts on your managed nodes by default. Take a look at it. If I come here and let me just go and say, I'm going to run an ad hoc command on Ansible 1, I'm going to run the setup command. And remember, the setup command is the one that collects the Ansible facts. And I'm going to pipe this to less. And here are all the facts that get collected by default from each managed node. Now I'm going to search for Ansible underscore distribution. And take a look at this. These are all the Ansible facts that start with Ansible underscore distribution. And sure enough, here is the Ansible distribution colon equals Red Hat. The same way we have it identified and listed in the when clause. And for this reason, this is considered a conditional. I know we spoke about conditionals, right? Using notify and handlers, but this is another way to use conditionals in your playbook using block and when. Lastly, this whole deal of block rescue always, now you know what a block is. So a block allows you to group pertinent tasks in one block, okay? But what happens if one task in the block failed, right? And I want other tasks to run, no problem. You can list that under rescue. So if the tasks, anyone in this case scenario, we have but one single task under the block, and it uses the built-in shell module, and we're basically running as a command, a shell command, a bash shell command remotely on the node. If this failed, no problem. Rescue will make sure that this task run, and it's basically using another shell command. Okay. Now, what do we need always for? Well, sometimes not only the tasks under block fail, the tasks under rescue may also fail. Remember, both are using the shell module. Well, in this playbook, we want the MariaDB server to be restarted. We want this task to always run, even if the tasks under block failed, even the tasks under rescue failed. We want the MariaDB server to always be restarted. The most important thing that I want you to know, this is done within a single task, but notice the indentation. It is indented with the name. It's indented with the name. So we've got block, rescue, and always all under the same indentation. And it's really important to keep track of your indentation when you use YAML syntax. And thank you for tuning in.